Now that we've seen how individual resistances and how you put resistors together, how they behave in series and parallel, and we've investigated capacitors and how they behave in series and parallel as well, and we've already been familiar with the power supply, we can build a circuit that now incorporates both resistors and capacitors together. So that's what I've done here. The circuit isn't hard to build, but let's take a look at it. What I've got is a power supply, and I remind you that for our purposes, the current dial needs to be turned up just a little bit, and then our voltage can be adjusted. And so what we've done here is I've preset the voltage to 6 volts, and so that's something that you ought to measure with your meter to make sure, in fact, although these are pretty decent, these are fairly new, they give you the display, so they're pretty trustworthy. We have a resistor, which I've preset him to about 500,000 ohms. So we've got a lot of resistance that's built up here. And you should, of course, check that individually to make sure that you're getting a trustworthy reading. And we have our circuit board from before, and I'm going to be using the 100 microfarad capacitor. So we have a resistor and a capacitor and a power supply that are all connected in series with one another. So this is known as a basic RC circuit. Okay, so what's its purpose in life? Well, the capacitor right now is uncharged. And we know that when we hit the switch, we have a certain pressure, voltage coming from the power supply. What that's going to do is that's going to charge up the capacitor. But the thing is, the size of the capacitor linked to a certain size resistance will cause a lag or delay in time before the capacitor charges up to its full value. So the way in which you can determine the rate at which that is done, well, we could introduce a meter. Alright, and so what I'm going to do is I'm going to now plug in on each side of the capacitor. And what I've got is I've got it set to the 2 volt setting. Let's dial that up a little bit to the 20 volt setting so I could read as many as 20 volts. And so the voltage that's going to be displayed on here is directly related to how much charge is accumulating on this capacitor. So let's take a look at that behavior. So all I've simply got to do is turn on the power supply, and we take a look at the meter itself, and we can see, disregarding the minus sign, this is the magnitude of it, that we see we have an increase that's taking place. So 6 volts coming from the power supply doesn't automatically correspond to 6 volts across the capacitor. It's taking some time to charge up, once again due to the size of the capacitor and the size of the resistance. So we see we're at 2 volts, which means 2 compared to 6, it's about a third fully charged up to this point. So you can control the rate at which a capacitor charges up by the resistance attached to the capacitor itself. Now, why do this? Well, we're certainly going to investigate it more fully in the lecture, so you'll see. So right now we can see that it's charging up, but what if we were to turn off the power supply? Then we can see almost right away, we see now that that's causing a release of electrons that have gathered on the capacitor, and so now we're in a discharging mode. We were charging the capacitor, and now we're discharging. So if we can control through a switch up to some threshold, a certain maximum voltage, and then we cut it off, that means that we have charging and discharging that can take place at a certain rate on the capacitor, and that controls many electronic functions throughout our electronic devices. So what you're going to be doing is you're going to be timing that. Alright, so you'll be teaming up with your partner, lab partner, and let's say every 10 seconds you're going to be making a note of what the voltage happens to be, so you can get a hold pattern on that and get a reading, and then when you release you get instantaneous readings. Every 10 seconds you can record what that is, and it turns out there's a special pattern at which a RC circuit charges up and discharges.